Hey guys. So this is going to be the review 2. Briefly, I'm just going to go over review 1, what we did, and then we will take a look at um, the second week. I'm not quite sure when we're going to be publishing these. It's either going to be on Fridays, sort of when we get around to it, or the following Monday. That way we will be able to get feedback from the TAs as to what you guys commonly did wrong. So week 1, we just went over data types and different types of inputs. So if you're having any trouble with that, make sure to go back and check that video out. For review 2, we've got some new stuff, right? In the second week, what did we cover? Well, or sorry, not second week. This was, I guess, the third week. It was MA2. So this is, I'll just write it out. This is MA2 concepts. MA2 concepts. Well, we had a lot of the data input, right? So we had data input, import, and export, right? Because we had you outputting both CSV files and .mat files. So this is CSVs and .mats. CSVs and .mats. What else did we have you guys do? So let me take a quick look here at the rubric, and we can see that, well, we had you do some basic algebra. Again, I'm hoping that that's not too complicated. Let's just briefly cover, though, everything with that. So we had you do some algebra. So the biggest thing here, the biggest subset of this is knowing the difference. Know the difference between, for example, dot times, which is element by element, and simply times, and this is matrix multiplication. So we want you to know this difference between the dot times and the times, just because if you don't, it's going to end up biting you. So that's why we've had it on the first MA. So really just make sure that you know that difference. Now, a big thing on this MA, and this was true on both problems, really, I guess mainly the second problem, was if we go to problem 2, we know we had to replace a bunch of values, right? So let's go and look. Let's look at that. So we did a few things. So we replaced values. And we kind of did this in a little bit of a weird way. And so I'm going to talk about this. So there's 2 ways we can do it. The first way is to delete and add, which is what we did in the MA, where we got rid of an entire column and then we added a new column. Or this is probably, so delete and add is the first. And then our second would be simply indexing locations and changing those locations. So I'm going to call this index and change. And so we'll go over both of these. And then last thing is we combined matrices. We combined a lot of matrices. So this is something that I guess, I don't know if it caught you guys off guard, but this is something that is going to be really heavily focused on in, I mean, probably your first several weeks, just because it's something that's so important. So we really, really want you guys to be aware um, of how to do that, and making sure that you're accurate with that. Because I can guarantee you on the first exam, there's going to be a question that's about combining matrices. Just because it's such a common task, and it's, I mean, sort of a not too difficult concept. So something that you guys should be able to master. Now, we combine matrices. Let me finish writing. So going through, I guess I've kind of explained already these two things, right? So this is element by element. This is matrix multiplication. Really, I don't know how much more detail I really want to get into. I would say refer to your class notes for those, or look up some guides online, really just because it's sort of basic stuff that you should be able to handle pretty quick. One other note we'll have with the algebra is that when we're doing, let me switch pens. When we're doing matrix algebra, so matrix, like addition, for example, just remember that the matrices have to be of the same size if you're adding them. Now, I know if you're a real MATLAB expert, you know that this isn't exclusively true, and that some matrices can have matrix operations done on them that aren't the same size. But in this class, we almost always are doing element by element matrix operations. And so that means if I have two variables, A, which is 2, 3, 4, 5, 6, 10, and I have B equals 1, 2, 3, 4, 5, 6, I can get a result A plus B. I can't do A times B, right? Because if I do A times B, and also say that this is no good, the problem with that is that the inner dimensions don't match, right? So this is a 2 by 3, right? 2 rows, 3 columns. This is also a 2 by 3, 2 rows, 3 columns. And so when you write this out, which you absolutely need to do on the exams, so that you don't confuse yourself. This is all, I mean, when we do the exam reviews, I'll harp on this a lot, but drawing out problems and writing things down on paper on the written portion of the exams helps a ton. So immediately you recognize, hey, my inner matrix dimensions do not agree. 1's 3, 1's 2, those aren't the same number. So we can't do matrix multiplication. Now, what we can do is A dot times B, right? Because A dot times B is okay because we're doing element by element. We're doing 2 times 1. We're doing 3 times 2. We're doing 4 times 3, right? So we're working basically sort of almost like pixel by pixel through the matrices. So just keep that in mind. Again, A minus B would be good. A dot divided by B would be okay. If you try to do other weird things with A and B, you're going to start doing, especially with divisors, you start getting really weird results as you're doing. What you're ending up doing is linear algebra, which is something that we'll cover in some of the later semester projects. So replacing values. First one we said we were going to do was delete and add, and so I will go ahead and do that one. So delete and add. What does this method look like? So this is sort of crude. I would say you almost will never use it. The reason we put it on the MA is because it's simpler, and it doesn't require quite as much knowledge on the front. And so since this was your first MA, that's why we have it on there. So if I'm using that same A, so A is equal to 2, 3, 4, 5, 6, 10. And say I want to replace the second column, right? So I want to replace the 3 and the 6. And what I want to do is I want to take those completely out, shift 4 and 10 over. So I'm shifting these over, and then I'm going to add a new column here, which would now be the new third column. So if I wanted to do this, how I would go about it is I would take, I would say A, and this is my MATLAB command window. I'd say A, I want all rows, right? So for all rows, I use the colon. I want the second column, so I'd say all rows, second column is equal to empty brackets. So this is open bracket, close bracket. Now, the result of this is going to be something that looks like this. It's going to be 2, 5, 4, 10, right? So this is the current matrix. This is what is equal to A right now. We've just completely removed the 3 and the 6. What we're saying is that the 3 and these locations, so all rows, the second column, these locations within A are equal to the empty set, which is nothing. So there's nothing there, and that shift happens. Now, alternatively, there might be a case where you say, okay, A is equal to 0. This would set these equal to 0. So you would have something that looked, you would have zeros here, right? But that's not the case we're working with, so I'm going to undo all this and I'll erase this bit. So as we move on, we say, okay, well, I need to put my new column on the side of A. So I say A, excuse me, A is equal to, we create a new matrix, we say A, and then because this new column vector is going to be to the right, we use a comma, right? Because commas move across rows, and so we're basically putting a last column on, which is moving in the row direction, right? Because we're adding a column here, so we're moving across the rows. So that's our thought process for doing this. So A, comma, then we have another bracket, and we say, okay, maybe we want 5 semicolon, because this needs to be a column vector, 5 semicolon 7, right? And then we close our brackets out, make sure everything's balanced. And this will lead us to 2, 4, 5, 5, 10, 7. And now, that's it. Now, on your MAs, obviously, these aren't hard-coded. You have to figure out how to get a column vector here, or if you're pasting a row vector at the bottom, how to do that. It's up to you to figure that out. These reviews are not really going to be intended for an in-depth analysis, because I'm not going to go and give your instructors lectures a second time. That's why you guys are sitting in lecture or should be sitting in lecture, and that's not my job. So this is just sort of a thought process of going through and doing that. So now index and change. I sort of hinted at it already. Index and change. We're just going to say we're working with the same A. So A, all rows, second column. We're working on the same problem. As I've got a hair on my computer screen. All rows, second column. And this time, we want to replace that second column with 5, 7. So we say this. And this will lead us to, 2, 5, 7 here, 4, 5, 10 here. Now, what MATLAB is interpreting this as is it's saying, okay, we have A, we have this variable. All rows and the second column of A, those locations within A are equal to the values 5 and 7. Now, there are, so this is very similar, right, then, to when I said equals 0 up here, right, when I was drawing out that example. So all of this, in the end, is about indexing. So being able to index your matrices and really think, okay, well, maybe I have my production numbers in each of my columns, and each row corresponds to a different year. Knowing that and having that information, that's the kind of things that you have to think about when you're working through a problem. So when it says replace a certain model of device, well, you think to yourself, okay, well, where's the device data located? So you say, okay, well, the device data is located in prod. And so if I have my device data in prod, then I know I want to replace a device. Well, I know the column that's associated with that because I asked for it in a menu statement, and that menu statement's output actually corresponds to the index. So I'll say my menu statement output, and then I think, well, wait a minute. I'm trying to get a column. So what I actually need to be doing is I actually need to move this over and say, wait, I want all rows and the column that's indicated by my menu statement. And then I want to delete these. So I do empty brackets. And so that's the thought process. That's how you go about solving the problem, and how you should think about the problem. Now, if we were asked, or if you were asked, hey, we realized that there is an error in all of our data from 2007, right? What you would do is the exact same thing. You would think, okay, well, where do I have my production data? Well, it's in the variable prod. So I know I'm going to be working in prod. And I say, okay, well, what data am I trying to get to? I'm trying to get to years. And each year is located on a different row. So I need to be taking out a certain row, and I know it's 2007. And so you can have some way of finding the 2007 row. So I'll just call it the 2007 T7 row. And then we want all the columns, right? Because we know all of our data from that year is corrupted. And so we say all, and then we set that to the empty brackets. So it's the same thought process, one way or another. And sort of the more you look at the data that you're given, and the more you think about it, the better off you're going to be. And this, again, goes back to drawing things out. So if you guys come to office hours, you know that all the TAs really like writing on the whiteboards, and that's because it's easier to see the problems when you draw it out, even if it's a basic example. So almost all of my matrix examples are in these 2x3, 3x3, 4x3 matrices, right? And the reason for that is because they're small enough to hand manipulate. And so if you're working on a problem, you don't necessarily need to be working or worrying about, oh my gosh, I have 10,000 data points, when maybe 10 data points is plenty to represent the data that you have and that you're working with. So drawing out sort of the most basic version of the problem is going to help you a lot. Now, combined matrices, this is our sort of last thing. And we actually already covered it, so I'm just going to go ahead and draw an arrow over here. And we can see how we've combined matrices. So A at this point, right, A, let me highlight. A here is this 2x2, so I'll color similars, right? And then this A is this matrix, and then this A is this matrix, right? So we can sort of see the flow going through. Now, when my A is yellow A, if you will, it's a 2x2. That means it has 2 rows. So, oh, I'm still on the highlighter. Whoops. So we have rows and columns. So when we have these rows and columns, we know that if we're trying to add a matrix to the right, it needs to have the same number of rows. And so if I draw this out just as an empty matrix, it'll make sense, all right? So if this is my one matrix and I need to add a matrix to the right, well, it has to have the same number of rows. It can have as many columns, it can have 100 columns, doesn't matter. It just needs to have the same number of rows. And so when we're adding side by side, right, we use this comma because we're adding another thing to the right. And if we are adding something below, right, so I'll pick a new color, we know it needs to have the same number of columns. And again, it can have as many rows as you want, but it has to have the same number of columns. Now, could I combine, the way I've drawn it, could I combine this red, this black, and this blue together? No, right? Because I've got this dead space here. So if I went through and I added my black to my red, well, then I've got, I don't know, maybe like a 15 column matrix. And then I'm trying to add a 3-column matrix to the bottom. That's not going to work, right? So really, really, really make sure that your matrices are the same size. I know that this is going to be one of the common problems on the MA. So I'm hoping that you guys are able to master this by the end of the semester, or hopefully by the first exam. So let's see here. I had one more note, I think. And so what we're going to do is we are going to talk just briefly about some of the functions that we have used. The main one being size. So the issue I've seen so far with size, and this has come from my time in office hours, is that you guys understand that you need to use size because you heard your professors say size in class and you went over it, and so you know, okay, well, I need to use it. I must need to use it. And you do. I don't want to say that you're always going to use it because that's probably not true. And oftentimes you won't even use all the information that you get from size. You certainly don't on this MA. So what I want you guys to do is, actually I shouldn't pull this up because this is, shouldn't pull up MATLAB because it has the students work on it. But go to the documentation and check out size and what it does and how it works. They have examples there that you can run yourself and see exactly what it's doing. If I took the size of A here, what I would do is I would say rows, calls, and I almost always use some version of rows calls, RC. Oftentimes I'll capitalize these just as we're going through. Rows columns equals size of A, right? And that would give me, well, it has 2 rows and 3 columns. So rows would then be 2 and columns would be 3. Now, if you're thinking, well, John, I get that I can do this. I can tell you what the function does. I just don't know why you're asking us to do this. That's a whole other issue. So the reason why we use size so often in this class is because we really, really, really need you guys to get away from hard coding. What we mean by this is when you hard code, it means that your code is not adaptable to a change in size. So when you hard code, hard coding is writing code that, whoa, man, I've mucked this up pretty bad, haven't I? Writing code that only works on one size of data set. So on your projects, on your MAs, we've seen this already in the ones I've graded. Some of you guys have taken in production data and assumed that, oh, well, I always am going to have 3 columns of production data in my first data set, so I should just hard code that into my menu statement. And that's no good. Hard coding that into your menu statement is a big problem because it either means that you're completely missing data or you're trying to access data that isn't there. So ways to work around this are almost always having to do with using size properly. So what we'll look for is, I'll just briefly go through the production example. So you want to say, okay, which either which year or which, the year is kind of easy because that's already stored. But if you want which device, and for whatever reason you don't want to use the device names, which are given, which is what you should have used. If you don't want to do that for whatever reason, and you want to say device 1 through however many there are, well, we know prod looks something like this, right? Where we have years and we have devices. And so let's see. In this one, we have 1, 2, 3, 4, 5 devices. Well, and we'll say that we know our first column is the year data. So if this is how our data is organized, where we have a column of year data and then 5 columns of devices, how do we not hard code this? Well, we take the size of prod, right? we set that equal to RC. And so we know something about our columns, right? We know that the device number, so I'll say device num, is equal to C minus 1, right? Because we have one column that's your data. We suppress both of these, right? Because we're good programmers and we don't like making our TAs super angry. And so we go through and we say, okay, well, we know our device, we know our number of devices. So now what we can do is in our menu statement, when we have our menu statement, we have blah, 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 someone yapping about whatever. And then we use num to cell, because again, this needs to be a cell array, or I think a string array might also work, but not a character array, which is a string. See how confusing this is? If you're confused about all that, go back and watch the first one again. We can use num to cell 1 colon device number. And what this will do is this, right? This vector here, in this case, is going to be 1, 2, 3, 4, 5, right? If we look over here, because we have 5 devices. If we had 6 devices, right, dev number would be 5. And, oh, right. If we had 6 devices, C would be 7, all right, because we have the year. Dev number would be 6, and we'd go 1 to 6, and so we'd have comma 6 here. And so num to cell is just changing it to cell array so that the function menu can read it. And if you're having trouble, like some students were, where you were trying to do this, where you just had 1, 2, dev number, then make sure that you're going and reading the documentation for menu, because really that will have everything you need in it. The documentation is just such a valuable tool. That's why you'll always hear myself and a lot of the other TAs talking about it, because it's probably the most useful tool you have available to you guys. The other part of it is that you have it on the exams. So at least for the typed portion of the exam, if you ever forget, it's like, oh my gosh, why is my menu statement not working? Well, you can go and you can check why your menu statement isn't working, right? So that's sort of what we mean by hard coding. This is how you get around it. And I think that is about it. So hopefully this gives you guys a good overview of what was expected from you on week 3. We'll be doing another one of these next week, and hopefully getting these posted on a quicker turnaround. But yeah, I hope you guys enjoyed watching, and make sure that you are coming to office hours if you're having any problems. One other thing about that, if you haven't turned off this video yet, God bless you. But office hours are going to be very, very busy on Thursday afternoons and Fridays. So my personal recommendation would be to check when online office hours are, and come to those if you can. Myself, Caitlin, Raul, and Laurel, who are all either current or former leads, are the ones that run those office hours. And so we love when we have questions in those. And it also allows you to visit from home. And so especially every Tuesday and Thursday, we have 2 of the online TAs, myself and Caitlin, in those office hours. So you've got plenty of help available to you online, and it's from 4:30 to 7, 4:45 to 7 technically, and so it's pretty late in the evening as well. So if you ever have any questions, please come in either to in-person or online office hours. Again, Thursday and Fridays are pretty packed, and so if you want to avoid that, you can come to the online office hours. And it's just the exact same experience, except for we do it on this little teleconferencing thing that I'm using to record this right now. Anyways, that covers everything that I want to talk about. I can feel my voice fading, and I want to cry a little bit. So that should probably be the end of the video, and I'll see you guys next week. Thanks for watching.